This is Ms. Loeffler with Lesson 48 in Algebra 1. So this lesson is about polynomials, degree, and addition of polynomials. So before we start, we need to define what is a polynomial. So there's different types of polynomials. The first example we're going to see is a polynomial in one variable. So a polynomial in one variable means that there's only going to be one variable. And basically, a polynomial is an algebraic expression that's a bunch of terms added together, added or subtracted. And so in the form of the polynomial would be something like this, ax to the n. So the a is the coefficient, the number that's multiplied by x, and the n is the exponent of x. And you could just have one term like this, or you could have a whole bunch of terms added together. So, for example, a polynomial in one variable could be something like 4x to the 8th plus 5x to the 7th minus 6x to the 6th, and so on. So we have a polynomial in one variable. We're only using the variable x in this polynomial, and then each term has a different exponent on it. And sometimes the terms are added, and sometimes the terms are subtracted. But each term is separated by an addition or subtraction sign. And it could go on, it could have more x's, x to the 5th, x to the 4th, x to the 3rd, and so on. So that's a polynomial in one variable. The degree of a polynomial, the degree is what is the highest exponent that it has. So for a polynomial with one variable, that's pretty easy to see. Generally, we want to write them in descending order, which means the highest exponent first, then the next highest, then the next highest, and so on. So the degree of this polynomial is just the highest exponent, which is just 8. So the degree of that polynomial is 8. So let's look at a polynomial in more than one variable. So when you see a polynomial in more than one variable, the form might look something like this. The form might look something like this, where it's ax to the n, y to the m, p to the z, and then so on. So in this case, we still have the coefficient a, the number that's being multiplied by the variables. And then we also have different variables. We have the variable x to a power, the variable y to a power, variable z, p to a power. And so that could be a polynomial all by itself, or it could have more than one term. So let's do an example of a polynomial with more than one variable. So here's an example, 4x to the 15th y m cubed plus p y squared and plus x squared dot 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 dot. So each term, this is a term here. Remember, terms are multiplied together and then they're separated by plus or minus signs. So far we have 3 terms. And now we can find the degree. The degree of a polynomial with more than one variable is a little bit more tricky. It's actually the sum of all of the highest exponents. So if we look at this one, we've got 3 terms. The exponent here is 2, an exponent here is 2, and then the p has an exponent of 1, so that would be 2 plus 1. So the degree of this term would be 3. The degree of that term would be 2. The degree of the first term would be 15 plus 1 plus 3, which would be 19. So this would be the term with the highest degree. And the term with the highest degree, so these are all degrees of each term. The highest degree would be the highest degree of the whole polynomial. So the degree of this polynomial so far is 19. So that's just a little bit of vocabulary that you need to understand for this lesson. And so now let's do some examples of things that we will do with polynomial expressions. The first thing we're going to do is add or subtract them. So in this example, please write this down. We're asked to add the polynomials, or in this case subtract, and write the answer in descending order of the variable. Descending order means that the highest power goes first, and then the next highest, and so on, all the way down to the lowest power. So, in this example, the first thing we need to do is get rid of the parentheses. And we know about adding like terms. We can actually just drop the parentheses for this first one. But for the second one, we have to use the distributive property because this negative on the outside of the second set of parentheses is going to change the sign of everything inside. So the x4 becomes minus x4, x to the fourth, and then plus 2x to the third minus x squared. So now that we've dropped the parentheses, we can go ahead and add like terms. So go ahead and combine like terms and simplify it. And then write it in order from highest power to lowest power. So now let's check the answer. We have to add like terms. So I would start with the highest exponent, 3x to the fourth, and negative x to the fourth. So that's going to give me 2x to the fourth. And then I would go on to the next highest power, which would be the third power. The only one with the third power is this term, so that would stay as positive 2x to the third. And then I would go to the second power, which would be negative 2 and negative 1x squared, and that gives me negative 3x squared. There's no x to the first power, but there is a constant, or just a regular number, which is positive 3. So what I've done is I've rewritten it in order from highest variable to lowest variable. And so this would be my answer. By the way, what's the degree of this polynomial? Remember, if it's just one variable, the degree of this polynomial is just going to be the highest power, so the degree would be 4. So let's do a couple more examples. So the first one, it's just like the last one. We're going to add these polynomials. So take a moment to write them down. We're going to add them and then write the answer in descending order of the variable. So checking our answer now for this problem, the first thing we do is we drop the parentheses. This first set of parentheses every sign had to change because the negative sign outside. And then the second set of parentheses, since it was a plus sign, you could just drop the parentheses. And then I rewrote the whole expression, the whole polynomial, like this. Once I rewrote the whole polynomial, I could just add like terms. So all the x to the fifth terms I added together to get that. All the x to the fourth terms, x to the third, and so on. And now that it's in descending order, we can easily see that the degree of this polynomial is 5. All right, very last example here. Go ahead and do the same thing here. So add these two polynomials and write the answer in descending order of the variable. Now checking our final answer, the first thing we do is drop the parentheses. The first set of parentheses can be dropped immediately, and then the second set we can drop them, but we have to change everything inside to the opposite sign, so that becomes negative 15, negative 2x cubed plus 6x squared minus 5x plus 3. Now we just have to add like terms. When we combine like terms and write it in descending order, we get the answer, which is negative 14x to the fourth, negative 2x cubed plus 9x squared minus 11x plus 5. Now that it's written in descending order, we can easily see that the degree of this polynomial is 4.